Our story begins over 4.5 billion years ago, in a time when the Earth was just a newborn planet, a chaotic and violent place. The young Earth was a fiery molten world, bombarded by asteroids and comets. These impacts were not just destructive. They played a crucial role in shaping the planet's future. These celestial wanderers, remnants from the birth of our solar system, carried within them a crucial ingredient: water. This water was essential for the development of the planet's surface and atmosphere. Locked within minerals and as ice, water arrived on Earth gradually. Over time, these minerals released their water content, contributing to the formation of Earth's early oceans. As the planet cooled, this water vapor was released into the atmosphere. Volcanic activity also played a significant role, releasing steam and gases that contributed to the early atmosphere. Over millions of years, the vapor condensed, forming clouds and unleashing torrential rains. These rains were relentless, pouring down on the planet's surface and gradually shaping its landscape. These rains, unlike any we can imagine, carved out the first riverbeds and filled the basins that would become our oceans. The relentless downpour sculpted the Earth's surface, creating valleys and canyons. The early oceans were likely acidic and hot, a stark contrast to the life-giving waters we know today. These primordial seas were a harsh environment, but they were also teeming with potential. Yet, within these primordial seas, the stage was set for a miracle, the emergence of life itself. Simple organisms began to form, setting the foundation for the complex web of life that would eventually flourish on our planet. The early Earth had an atmosphere vastly different from our own. Thick with carbon dioxide, methane, and ammonia, it lacked free oxygen. These early gases, however, played a crucial role in the development of life. Within the protected depths of the oceans, shielded from the harsh radiation of the young sun, life emerged. Simple, single-celled organisms, our most ancient ancestors, arose in these warm, chemical-rich waters. These first life forms were extremophiles, thriving in conditions toxic to most life today. They survived by harnessing energy from chemical reactions, a process known as chemosynthesis. These early pioneers began to shape the planet, their activities releasing gases that slowly changed the atmosphere. A dramatic shift occurred with the evolution of photosynthesis. This process fundamentally altered the course of life on Earth, setting the stage for the complex ecosystems we see today. Around 3.5 billion years ago, a new type of organism emerged: cyanobacteria. These tiny yet powerful organisms were among the first to perform photosynthesis, a process that uses sunlight to convert carbon dioxide and water into glucose and oxygen. These microscopic creatures possessed the remarkable ability to harness sunlight, converting it into energy and releasing oxygen as a byproduct. This not only provided them with the energy needed to thrive, but also began to change the composition of Earth's atmosphere. This great oxygenation event was a turning point in Earth's history. Before this event, the atmosphere was largely devoid of oxygen, and life was primarily anaerobic, meaning it did not require oxygen to survive. Oxygen, toxic to many early life forms, began to accumulate in the atmosphere and dissolve into the oceans. This accumulation of oxygen had profound effects on the planet's environment and the types of life that could survive. This led to the extinction of many anaerobic organisms, paving the way for the rise of oxygen-breathing life. The oceans themselves transformed, becoming rich in oxygen and supporting a new diversity of marine life. Iron dissolved in the waters reacted with the oxygen, forming vast iron oxide deposits. These reactions caused the waters to turn red, a phenomenon that can still be observed in certain iron-rich bodies of water today. These deposits, visible in ancient rock formations, serve as a testament to this pivotal period in Earth's history. They provide a geological record of the dramatic changes that occurred, marking the transition to an oxygen-rich atmosphere and the dawn of a new era for life on Earth. While life was evolving in the oceans, the Earth's surface was far from static. The Earth's crust, broken into massive plates, was in constant motion. This process, known as plate tectonics, shaped the continents and oceans we know today. Over millions of years, continents collided and separated, creating vast supercontinents and then ripping them apart. These movements had a profound impact on Earth's climate and the distribution of water. Mountains rose, creating rain shadows and altering weather patterns. Shallow seas formed and disappeared, impacting marine life. The continuous dance of the continents continues to this day, a powerful reminder of our planet's dynamic nature. Section 5. From ancient seas to mass extinctions, life and death in the oceans. The story of life in the oceans is one of both incredible diversity and dramatic change. Over billions of years, the oceans have been a cradle of life, nurturing countless species and ecosystems. The oceans have been home to an astonishing diversity of life throughout Earth's history. From the smallest plankton to the largest whales, the variety of life forms is truly staggering. Each species plays a unique role in the complex web of marine ecosystems. From the Cambrian explosion, a period of rapid diversification 500 million years ago, the ocean saw an unprecedented burst of life. This era marked the emergence of many major groups of animals that still inhabit the seas today. To the reign of the dinosaurs, when massive marine reptiles and fish dominated the waters, these ancient creatures were the rulers of their underwater realms, showcasing the adaptability and resilience of marine life. Life in the oceans has constantly evolved and adapted. Over millions of years, species have developed remarkable adaptations to survive in diverse and often harsh environments, from the sunlit surface to the dark abyssal depths. But these periods of flourishing have been punctuated by times of great upheaval. Volcanic eruptions, asteroid impacts, and other natural disasters have periodically disrupted marine ecosystems, causing significant changes in the composition of ocean life. And rapid climate change have triggered mass extinction events, leading to the loss of countless species. These catastrophic events have reshaped the oceans, often wiping out dominant species and allowing new ones to rise, wiping out vast numbers of species. The aftermath of these extinctions has seen the emergence of new life forms as ecosystems slowly recover and adapt to the new conditions. The Permian-Triassic extinction, 252 million years ago, stands out as the most severe extinction event in Earth's history. This event decimated marine life, drastically altering the course of evolution in the oceans. It's thought to have been the most severe, causing the extinction of over 90% of marine species. The scale of this devastation is almost unimaginable, yet it set the stage for the evolution of new life forms. Wiping out over 90% of marine life, this near-total wipeout of marine species was a turning point, leading to the rise of new organisms that would shape the future of oceanic life. These events, while devastating, have also created opportunities for new life to emerge and thrive. The resilience of life in the oceans is a testament to the enduring power of evolution, as new species continue to adapt and flourish in the ever-changing marine environment. Section 6. Earth's water today. A precious resource under pressure. Today, water covers over 70% of Earth's surface, a testament to the journey it has taken over billions of years. This water is in constant motion, evaporating from oceans and lakes, forming clouds, falling as rain and snow, and flowing back to the seas via rivers and groundwater. This hydrological cycle is vital for life, but it is under increasing pressure from human activity. Population growth, industrialization, and agriculture all place immense demands on our freshwater resources. Pollution from industrial waste, agricultural runoff, and plastic waste threatens the health of our oceans and freshwater ecosystems. We are changing the very chemistry of the oceans through our actions, with potentially devastating consequences for marine life. Section 7. A changing climate, a thirsty world. Challenges for the future. As we look to the future, the challenges facing Earth's water become even more stark. Climate change, driven by human emissions of greenhouse gases, is already disrupting weather patterns, leading to more frequent and intense droughts, floods, and storms. Rising sea levels, a consequence of melting glaciers and thermal expansion of ocean water, threaten coastal communities and vital ecosystems. Competition for scarce freshwater resources will likely intensify, leading to potential conflicts and displacement of populations. The choices we make in the coming decades will determine the fate of our planet's most precious resource. Section 8. Quenching Earth's Thirst, Innovation and Adaptation. Despite these challenges, there is hope. Technological advances in desalination, the process of removing salt from seawater, are making it a more viable option for freshwater production, especially in arid regions. Water recycling and reuse are becoming increasingly common, reducing our reliance on freshwater sources. Farmers are adopting more efficient irrigation techniques, minimizing water waste, and improving crop yields. Protecting existing ecosystems, such as wetlands and forests, is crucial. These natural systems act as sponges, absorbing and filtering water, replenishing groundwater, and mitigating the impacts of floods and droughts. Section 9. Water, the final frontier on Earth and beyond. Our journey with water is far from over. As we strive to manage and protect this precious resource here on Earth, we are also looking beyond our planet. The search for extraterrestrial life invariably involves the search for water. Mars, with its polar ice caps and evidence of past liquid water, holds the tantalizing possibility of harboring microbial life. The icy moons of Jupiter and Saturn, with their vast subsurface oceans, may hold even greater potential. The story of water is ultimately the story of life itself. From the fiery birth of our planet to the search for life beyond Earth, water is the common thread that connects us all.